Hello, and welcome to this presentation. Today I'm going to be talking about math in AAC. This presentation is in two parts. So the first part is about teaching math vocabulary with AAC. We are going to take a look at some of the barriers that students with significant disabilities experience in terms of their access to learning opportunities and how their physical and communication disabilities impact learning. We are also going to talk about the necessity of context, the importance of learning being rooted in real-life experiences. Then we're going to dive into language and talk about how important language is as a part of math and how it is a tool for learning math. And the final part of part one is taking a look at 3 strategies for teaching math language that we can start using right away. The second part is about teaching math content with a formula. We're going to take a look at that formula, figure out how it works, how we can use it with our students. Then we're going to walk through 2 examples of using that formula. And within these examples, we're going to take a look at the language objectives that we should be working on and consciously be teaching our students while we're teaching math content. So here we go. So let's start with part 1, teaching math vocabulary with AAC. We begin, it's important to really zero in on who we are talking about. This presentation is about supporting the learning of our non-speaking and significantly disabled students and gaining appreciation and understanding for the numerous barriers that they face in early learning. Erin Sheldon describes these barriers so perfectly in the context of literacy. And I've adjusted her words here to replace literacy with math because I cannot say it better than her. So I've taken some liberties with this quote. Erin, please forgive me. She says, "Students with complex communication needs develop language and math skills along the same developmental continuum as their peers. However, they often arrive at school with limited experience of typical early math and language activities. They may have had minimal experiences to develop mathematical thinking and problem solving by building and playing because of their physical and communication disabilities. They have often spent more time in medical appointments and therapies and less time learning about size and shape. They often have sensory needs that make it difficult to see, hear, and process the language of their environment." End quote. Due to many reasons, the quality and quantity of their early math experiences creates this opportunity chasm between learners and their non-disabled peers. Some of our learners are at the very beginning of developing mathematical thinking, and our instruction must meet them where they are at. So today's presentation will look at young learners through a disability lens. How can we make early math content and language accessible to them so that we can set them on a path for learning? So to start us off, I want to talk about mathematizing in our everyday. What is mathematizing? Alan Rosales, who I will reference a lot in this presentation, says that it's the process of understanding math within the context of children's daily lives. It's the ability to think about math while playing, cooking, cleaning, etc. Alan gives this example from his childhood, which so perfectly illustrates mathematizing. He says that he remembers being 5 years old at the grocery store with his mom, and she engaged him in a fun learning experience. He says that while they were shopping for fruit, she would say, I wonder how many bananas we will need for the week. Should we buy the big cantaloupe or the small one? Which fruit do you think is heavier, the cantaloupe or the orange? Why do you think the cantaloupe is heavier? Alan's mom was using words like how many, big, small, and heavier, which was a way to infuse math into their real life. So mathematizing is a way to promote mathematical thinking while modeling math vocabulary, while you're doing something meaningful, just like in your everyday life. Early math learning is rooted in context. Much of it takes place socially and during play. Kids explore and discover with their senses, touching and looking, and begin to start wondering and thinking about the nature of things. This learning is rich and multi-layered. They're learning to ask questions and describe things using language. And this language and thought starts to create the foundation that will later support them with conventional math learning. But for students with disabilities, they may not have had these early learning experiences that were social and play-based. And so they're missing out on that part. They don't have that same foundation as their peers do. And then when they come to school, we think, oh, okay, how do we support them in making this math lesson accessible? And because of the nature of their physical disability, sometimes the activity gets really distilled to like what we think is the most essential piece, like teaching a numeral with a flashcard. And, I think this happens because we might not know how to adapt and create these kind of play-based experiences where they can, experience quantity and explore quantity. And so because we don't know how to make these adaptations, we think, okay, what do we need to teach them? We need to teach them the number, and then it becomes this very rote type of exercise without really digging deep behind what that numeral means. But doing all that surface level learning only takes you so far. Students need to develop a deeper understanding. It needs to be contextualized. I'm going to say this so much today. What does that mean, though? Like, it needs to be contextualized. I like this example from Kane and Faulkner. They have this little kind of thought experiment that they use that's called like a 3 is not a 3. So when we think about 3, the numeral 3, that's an abstract symbol. It's a picture, essentially. Students can learn that symbol for 3, but they don't necessarily know what 3 is or experience what 3 is. So we have to help them make that connection between the abstract, the symbol, the numeral 3, and the concrete concept, like holding 3 things in your hand, experiencing that is 3. It's similar to words, to writing. Cat, the letters C-A-T, they're abstract symbols and they represent a cat. And even that picture that I have there of a cat is also a symbol too. But it's a totally different thing to learn to read the letters that make the word cat, or to see a symbol of cat and experience a cat, to touch a cat, to hear a cat meow. So we want to ensure that we are setting up our students to be making these connections between the abstract and the concrete in all of their learning opportunities. Kane and Faulkner talk about applying the same strategies that we use for teaching reading comprehension as we do for teaching like the concrete knowledge, the concrete understanding behind the numeral. And I think this is a really nice parallel to draw. So when you think about it, like developing these understandings of the concrete really kind of are like reading comprehension, because reading comprehension is all about meaning, making meaning, understanding. And both of these things are meaning-based processes, developing that understanding of the concrete and reading comprehension. They're both based in meaning. So in both situations, we are supplying the context. We are helping students draw connections. We are building background knowledge. We are hyper contextualizing, making connections to their life, helping them see how those words on the page are connected to language and meaning. So we do the same thing with math. We have to help our students learn that these numbers, these symbols mean something, and they can experience what they mean to really make that deep connection. So they don't just learn that a 3 is a 3 and it looks like a 3, but they don't know what a 3 feels like. Part of developing deeper understandings is talking and communicating about the things that we are learning and experiencing. So we really have to think of communication as a very important tool for learning. It's a tool for learning everything, and it's also a tool for learning math. And we don't necessarily think about language right away when we think about math, but it is such a vital part in making those deeper connections and deeper understandings. Communication is absolutely critical to developing mathematical thinking. And our students who use AAC are in this unique position where they can only learn to use the words that we give them access to. So we have to ensure that that vocabulary is in there. I use the analogy of knitting a toque because I want us to just keep in mind when we are teaching this vocabulary, we want to be referencing it within our students' aided language system. Remember, we're teaching them a language. We're teaching them an aided language. So the words that we're referencing, the words that we're teaching them, they should always be in their system and not somewhere else. Every time we model a word in their system, it's like we're knitting a row on our toque. Every time we're going back to that system, modeling from that system, we're knitting more and more rows, getting closer to finishing our toque. If we are modeling that vocabulary somewhere else, like on a standalone symbol, that's not in their communication book, that's not accessible to them, it's like we're knitting rows on different projects every time we model. It's not all working towards teaching them that one language that they have access to. Math vocabulary and math language is very precise, and when we teach kids about the nuance of this precise vocabulary, we're helping them create deeper understandings of math. So let's take a look at this example of 10 units and a line of 10, a rod of 10. If you asked a student, are they the same thing? If the student understands the idea of sameness, they might say, no way, like they're not the same thing. Look at them, they're different. One's long, the other is made of a bunch of small pieces. They might be looking at a different feature of sameness. Whereas if you ask with more precise language, are they equal in value? Then you're really getting to the root of the question you intended of how do we compare these values? Do they have the same value? Are they equal in value? Alan Rosales talks about math vocabulary in 3 categories. He has math content, reasoning, and proof language. So math content is the language that we use to talk about the math concept, like talking about the thing we're doing. Maybe describing it as tall if we're talking about height and measurement, or short. Reasoning language is the language we use to make sense of the problem. So this is words like more than, less than, equal to. And proof language is the language that we use to support a statement with evidence. So it's like explaining how it's bigger, saying it's 3 more than the other one. It's 2 less than that one, that type of language. Here's an example with volume. So content language, when we are teaching about volume, could be using the words empty and full. Whereas reasoning language could be words like top, bottom, space, more, less, the same. And then proof language can be categorized into categories, non-standard and standard measures. So non-standard measures could be like the type of container that you're putting the water in, or the number of containers. And standard can be just regular measurements like cups, ounces, pints, gallons, and so on. So there's a lot to think about in terms of language. We have to be really intentional about what words we are going to model, what words we're going to teach our students. And I really like this framework from Alan Rosales because it gives us an idea of some of those words that we need to be showing our students during these activities. And we also have to make sure that those words are in their system. They have to have access to those words. When we give our students access to these words, when we teach them how to use them, and these words exist within their robust AAC, we are also supporting the idea of interdependence for disabled students. Much of early math learning happens with manipulatives, and manipulatives are really a way for learners to use something concrete to think with. But for our students with disabilities, if they don't have use of their upper extremities, they aren't able to manipulate concrete things in the same way as you or I might. So even if they can't manipulate manipulatives with their hands, if we give them the words to talk about manipulating manipulatives, adding things to a pile, taking them away, they can actually direct someone else to do this. And there's really interesting research on this, and it shows that even if you're directing someone else to move the manipulatives and you're in control of that, it still has the same positive effect of using it to help you think, using it as a concrete way to think. So this is just yet another argument for really building the language and communication of our non-speaking students so that they can direct others to help them in doing that learning and thinking. So let's get into the strategies that you can start using today. How can you start to be infusing some of this math, language, and vocabulary into your day-to-day? How can you start to teach your student to use these words in a naturalistic way? So we're going to look at 3 strategies: spiral talk, modeling small numbers, and encouraging the use of voice when counting. So let's take a look. The first strategy is spiral talk from Alan Rosales. It's a strategy to help you be intentional about teaching specific math language with the student's AAC system. The idea with spiral talk is that we're just bombarding them with one target word, and we're using it over and over. We're repeating it multiple times while we're playing or doing something. An example of this, recently I was playing with a student and we were stacking cups and we're modeling add all the time, using this spiral talk strategy to just bombard her with the word add. You're adding a cup. You're adding another cup. I'm adding a cup. Simon added 2 cups. Let's add more. Just saying this over and over again and modeling it in their system. It's a really neat way to introduce some of this math language intentionally because, to be honest, I think in this type of scenario, we might just be modeling typically the word more, but add has a different meaning to it, slightly different. And it's an interesting way to start introducing some of those different math words during play. Thinking about our students with significant disabilities, maybe with physical disabilities, we can still use spiral talk to be describing what we are doing too. So if our students aren't playing with their hands, we can still use this strategy in the same way to talk about what we are doing or what we are seeing and just be bombarding them with that vocabulary word. Our next strategy is modeling small numbers. So this is a strategy to help students make that connection between quantities and numerals. So remember when we talked about the abstract form of the numeral and connecting it to the concrete? This is a way we can do that in our everyday life. We're just pointing to the numeral in their AAC system when we're talking about the quantity verbally. And we do this in a way where we're making comments. We're not asking questions. It's not a quiz, but we can make comments about these small numbers as they come up in our everyday life. So we can say like, there are 2 of us riding the lift. Or here are your 2 AFOs. I have 3 books for you to choose from. I'll clean up the 2 cups. I see 5 kids in the gym. Do you want to add 2 pom-poms or 3? So why do we want to model small numbers? We want to do this because it helps teach our students to subitize, to instantly see how many there are. Most humans can only subitize collections of up to 4 or 5 objects. And the human brain can't see like beyond 4 or 5. Once it gets beyond 5, you start to break it up into smaller pieces. And this goes for adults and for children. So we combine smaller numbers in order to comprehend what the whole collection is. So for instance, you don't see 7 if there are 7 dots. You're going to see it in pieces like 4 and 3 or 5 and 2. You won't just see 7 dots and be like, oh, that's 7. Your brain will break it up into smaller parts. So when we're pointing out small numbers in the everyday, we're helping our students to start to do this, to recognize, to subitize, and instantly see how many there are. The third and final strategy is about encouraging the use of voice when counting. For students who are non-speaking, we want to be encouraging them to use their inner voice inside their head. And we want to do this to help our students use their voice inside their head to count. Counting with your voice is an important and early milestone, and it usually is how students first identify quantity. So we might ask them like, how many is this? And they'll count. They'll use their voice to go 1, 2, 3. It's 3. So we want to give our students the same kind of strategy and be telling them that they can use their inner voice. And you can also use an external voice. You can use something like a multi-message voice output device, like a step-by-step, and sequentially program like 1, 2, 3, 4, 5 on each of the steps. And then you can do the same thing, like hit the step-by-step, and it can say 1. So that's like a way to externalize that voice as well, and just hit that as you're, counting along the number of objects. So whether it's internal or it's external through assistive technology, we want to be giving them this strategy and kind of mirroring what typically developing students do, and encouraging them to do that and use that strategy in their own way. Okay, we've made it to part 2. Part 2 is about teaching math content with a formula. So this formula is really simple. It's just 3 parts. When we're setting up a math experience or we're teaching a math lesson, we want to be thinking about including these 3 elements in that lesson. So the first part is a touchable, visual, tactile thing that can represent the quantity. So it's concrete. It's something that you can touch and feel. That's the first part. Our second part of the math content teaching formula is a discussion to make sense of what you're doing. And this is, of course, with language. So we're discussing the concrete thing, we're describing it, we're talking about it, we're using our AAC to talk about it. And the third part of this formula is just to record what we've talked about, to use symbols, use numbers, use words, to keep a record, to make a note about the thing that you have done. So this is just a simple formula to always be embedding that concrete thing and also embedding the abstract, having both of them there and having language in the middle, talking about it, talking about what we're doing, putting vocabulary to that. So it's a nice way to just kind of encompass all of these different elements that we need to be covering. So let's look at an example for a student with significant disabilities who uses PASS, partner-assisted scanning, to communicate. So this is a student who loves Squigs, those little suction cups, and they're a great manipulative to use in math, and one that is really accessible to this example student. He can pull them off of things one by one in a way to count the quantities, and so what a great tool to use to be comparing quantities. So his goal in his competency-based, his CBIEP, is I can communicate an understanding of comparing quantities. So let's take a look at this goal and this activity. So we're going to cover these three components. We're going to have our concrete, manipulative, the touchable thing, the visual thing, our Squigs. And then we're going to have our pod book, and we're going to take a look in more detail at some of the pages that we can use, some of the words we can use in this type of activity. And then we're also going to look at the symbols that we can use to represent these quantities that we're talking about. The concrete, this is the most simple thing. It's just our Squigs. Yeah, we just need something to be touching and exploring, something to root our learning in. Remember when we were talking about context earlier, we have something to explore and learn with. We use manipulatives to think with. The second part is the language part, the discussion of the concrete. So we're going to look to our pod and see what kind of words we can use to be talking about comparing quantities. Now, the beautiful thing about having a robust aided language system like POD is that there's plenty of math language that's already in there. So when you're doing an activity like this, you can flip to a page like number 24F, which is a number page, and it's a quantity page, and it has some of this vocabulary that really makes sense to use in this activity, like more than, less than. So that's the first piece of it. But we can also go a little bit deeper, identifying some of that math language that's associated with the math goal. And we can use that idea from Alan Rosales when he talked about the 3 different kind of categories of math language I mentioned earlier. So what could content language be for this type of activity? It could be words like group, all, that, and this. So the words that we might use to talk about the manipulatives, to talk about the Squigs. So we could be saying like this group, that group, all of them, using those kinds of phrases, modeling that with POD. And then the reasoning language, making sense and describing what we're doing. Words like more, less, difference, same, amount, total, equal to. So that we can talk about what we're doing and describe it with this vocabulary, ask questions. Is it more or less? How many more? They have the same amount. This group has more. This group has 2 more. Oh, that's a proof language. So proof language is describing, giving like the detail, the explanation of how and kind of why. So you might be saying that one group has 2 more, using numbers, or saying like has 2 more Squigs, that kind of language. So you can use a table like this to really plan out and be intentional about what words you're going to model. Keep yourself accountable to like, okay, what words are we teaching associated with this math content goal? And just, figure that out and then roll with that. So the third part of this formula is learning to record the ideas using symbols. This is the abstract. If we're comparing quantities, we can talk about numbers, the numerals, the symbols in POD. That, of course, exists. We can also represent it in other ways. It's just about connecting the quantity to the numeral and just showing students like, hey, these 2 things are connected and they mean the same thing. So that little example just shows you it just takes a little bit of planning and thought. How are we going to use that formula to make sure that we're covering all of our bases in terms of using manipulatives, using concrete things, infusing language into our math instruction, and then finally helping students make that connection between the symbolic and the concrete by recording that information. We're going to take a look, thinking of the same student in mind, thinking about the same type of CBIEP goal, but just really digging into that idea of repetition with variety. We want to be doing different things to be teaching that core goal, different activities, and we can be looking at different vocabulary words as well. So the second example just kind of highlights how there is so much nuanced language involved with math. And even though the CBIEP goal is the same, I just want to highlight how different the words are and the vocabulary is. Of course, there's overlap, but it's just interesting to think like, wow, there is so much language that we need to teach in regards to math. There's so much language that we use. So this is comparing quantities again with POD, partner-assisted scanning, but this time it's thinking about height. So in this type of activity, we're building towers with blocks, and because this student has physical disabilities, they can use the switch to control their little car to knock the towers over. So we can involve the student in building the tower, making this kind of airless by saying like, should we add 2? Should we add 1? And having them make those choices, building the blocks together. You can be modeling the vocabulary. And then at the end, they can, with their switch, knock over the towers. So just, thinking about a way that they can participate in more than one way. So let's take a look at the formula. Same thing. We have our concrete, our manipulative, it's our blocks, our units. They are non-standard units. Then we have our pod, of course, as the language piece, the discussion of the concrete. So the thing that we're going to use to infuse that math language. And then finally, the symbolic, the numerals page in our pod works great for that. So our concrete, our blocks, we don't have to say much more about that. Let's take a look at the language now. So pod comes with an already pre-made blocks page, which is page 36. And I want to point this out because I think when I was thinking about math words, I was thinking right away like, I need to make my own special pages. And then the more I looked, I was like, no. Pod is so robust that these words do exist in there. You just have to know where to find them. If you're doing an activity like this, the units, blocks will be in there. Descriptions of height, tall, that's in there on our blocks page and more. And then, of course, different verbs associated like put on, or you could use add if you're adding blocks. There's these different types of words, and I've written there that like more is an operations word. It's a reasoning language word. Tall is a measurement word, but it's also part of that content language if we're thinking of Alan Rosales' table. And then blocks, which are countable noun, they're part of proof language. We can say 1 block, 2 block when we're describing how they're different. So let's take a look at the words that we could use in this activity. We've talked about some of them, but we have content language can be tall, short, long. The red tower is tall. The blue tower is short. Modeling those kinds of phrases and words. We can use reasoning language like more and less. That's an overlap with our last activity, which is great. Lots of repetition there. And then blocks and numbers as part of our proof language. I just wanted to highlight a few other places in POD where you'll find some of these words as well. Comparing heights, On the size page 24E, we have tall, short, long, so you can use some of these measurement words in this activity and other measurement words in different activities. So they exist in this robust system. And we saw this page 24F in the last example too, which has this reasoning language of more than, less than on here as well. I think it would be good to add equal to on here. So then that brings us to the third part of the formula, that's recording the abstract, recording our symbols. So we can use numerals to be describing that and using some of that proof language as we're describing the numerals. So that is our formula. That is how we can pull in math vocabulary and language into these learning opportunities. And I think the formula is just such a nice way to make sure that we're covering all of our bases, making sure that we have those manipulatives in there. We have our robust AAC system that's there that we can use to be talking about these connections and helping our students understand the precise math language. And then helping them in the third step to connect the abstract numeral to the quantity. So what a great formula. It helps bring this all in. And then, of course, we can use like the content language, reasoning language, proof language, that kind of table to help us plan and be intentional. So kind of just brings it all together. I hope this gives you some ideas about how you can be teaching math, language, and vocabulary in the everyday. You can be mathematizing in your daily lives with your students and teaching them this vocabulary with their pod system or their AAC system. I also hope that the discussion of the math formula gives you some ideas about how we can draw in these three elements into our instruction to make it good instruction for our students. Thank you so much for listening.